Okay, in this video we are going to see two fields applied to electronics. For starters, there are active filters with amplifiers and passive with resistors, capacitors and coils. Also, there are high pass, low pass, band pass filters and reject bands for other one to other as necessary. To determine the variable of a field and its transfer function to our purpose, the coefficients to be used so that the field has a great variable. Let's start about the Butterworth field. The Butterworth field is characterized by having a pass band similar to ideal. It is also characterized by better authentic in its transfer function in this. A table is presented that shows the transfer function necessary to obtain the circuit necessary order. Since the Butterworth field varies only in this denominator, the numerator never changes. Here we can say the behavior of the Butterworth field when we change the order of the transfer functions. We can note the distinct change between order 1 and order 3. We see how the slope is more striking, but we can see that from order 6 onwards the slope of the line is similar. This is important to evaluate because as the order increases, the complexity of the transfer function we solve increases. In the MATLAB program, we can obtain the transfer function to be able to pass it to a real circuit. This reduces the design time and increases the effectiveness of the result. We can see that the function requires three parameters: filter order, cutoff frequency, filter type, and free type. With this, the program gives of the transfer function that we can solve graph. Here we can say Butterworth in low pass and high pass configuration with the help of the program. And here we can save the beautiful file in bandpass configured and in the band reject configured. And we can see that the request parameters are the same of the different orders that are grave. That were grave. Now we introduce the Chebyshev filter. It's a field that is characterized by the fact that its passband has a more steep slope than that of the previous filter, and feathers occurring on the band. Its transfer function is this in increments are the orders that can be applied to the function. To find the curve, this equation is posed. The Chebyshev field comes in two types. Types 1 characterized but having only poles and a constant ripe that pass band, and type 2 that is characterized but having polars and zeros and a constant ripe in the reject band. The MATLAB program allows to optimize the transfer function of the Chebyshev circuit. For this, four parameters are needed: feed order, peak-to-peak ripe factor, cut-off frequency, and filter type. With this, we can obtain the transfer function to necessary order. With this program, we can also grab the functions of the twice orders. There can see the capital filter to low and go high. Here we can see the Chebyshev filter pass band and reject band. Finally, we have the graphs of the Chebyshev filter type 2 in these four different configurations: low pass, high pass, pass band, and reject band. And in conclusion, we can observe the two fields in low pass configuration, evaluate, evaluating their gain with respect to frequency. We see how the Chebyshev filter is close to having a steady slope than the Butterworth. This is important to know when decide the filter to use. The two filters have characteristics different and cover a larger number of applications in everyday life. Thank you.